Hello and welcome. This is Chapter 5, Section 2, Verify Trig Identities, Part B. So we're going to continue what we did yesterday, but it will be a little bit more lengthy than we were before. So we're going to add in a couple new skills that we haven't used yet. So the first thing is let's rewrite this as sines or cosines. One of the biggest strategies is rewriting everything as sine or cosine. So this is the sine of x over the cosine of x. Plus the cosine of x over the sine of x. That is your quotient identities. So because tangent and cotangent aren't the same, I like to rewrite everything as sines or cosines. It's not always the perfect rule, but it makes it a lot easier to do if you just rewrite stuff as sines or cosines. Now, what we're going to do is, well, these are two fractions, and I can add two fractions together by making a common denominator. So I can multiply by cosine of x over cosine of x, and sine of x over sine of x to both sides of, or both of these fraction parts to make a common denominator here. So we're going to rewrite this as, so we're going to use these algebra skills to rewrite this as sine square root of x over sine of x cosine of x plus cosine square root of x over sine of x cosine of x. So when you're doing this on Alex, you don't actually write this part, but on paper you'd want to write that you multiplied those. This is the step you would write on Alex, this red step here on Alex, this blue step here on Alex. Now, when we go to the next one is I like to write this now as a combined fraction, so sine squared plus cosine squared of x, all over one single thing, sine of x, cosine of x, which is algebra again. I believe if you wanted to, you could have done that in the blue step, but I like adding that extra step. They have common denominators, so I can add the tops together. Now this is a Pythagorean identity, which is just in fact 1. So this is in fact equal to 1 over the sine of x cosine of x, and that is by that Pythagorean identity. Now notice how this 1 is actually going to both of these. So I could actually, well, in theory, I could actually use the reciprocal identities. Well, in practice, I can too. So the sine of x, I can rewrite it as cosecant on the numerator, and I could rewrite this as secant on the denominator, or on the numerator here as well. So notice how that is actually the answer I want. So I'm going to go ahead and move this up. And using this, I'm going to move this up top and move this up top by just writing them as their reciprocals. So sine and cosecant of x are reciprocals, so I moved it to the numerator, and then move cosine up top as secant of x, which again is another reciprocal identity, and therefore I get to my final answer using that last reciprocal identity. So let's do another thing here. So it gets a little bit more complex because there's a lot of stuff you'll have to do. I'm going to rewrite everything as sines or cosines. So let's do some algebra. So let's rewrite secant as 1 over your cosine of x, and then we still have minus cosine of x. That's just the top of that fraction, all divided by, well, secant again is 1 over cosine of x, and then we have plus cosine of x. So that is just some algebra that we're doing. Now, on your paper is how I would do these. So then the next step is, well, we have a fraction and a kind of a whole number, let's call it. It's not really a whole number. We're going to combine these together by making a common denominator. So this one on the left is dividing by cosine, so this one has to be dividing by cosine. So I can just multiply by cosine of x over cosine of x, which is just 1. So if I just multiply by cosine of x over cosine of x to both of those, what happens is that I get 1 minus cosine squared of x over that cosine of x. So I can combine this as 1 minus cosine squared, and putting it as one fraction, you can put those together over cosine of x. Now I can also do that on the denominator as well. So this is all divided by, well, we'll have 1 plus the cosine squared of x over the cosine of x, which is some more algebra. So we could have done this as multiple steps like I did before. So I could write this as 1 over cosine plus cosine squared over cosine. and wrote that down first and then combine it like this. It's up to you. You can do it as many steps as you need as long as they are okay. I just ended up doing it this way because it makes it a little bit clearer and neater. Now we have a fraction divided by a fraction, so we're going to keep change flip. So doing some more algebra, that was supposed to take long, so let's move this up. Let's keep change flip. So the top will remain the same, so 1 minus cosine squared of x over cosine of x. And then we will keep change flip, so it ends up being cosine of x over this 1 plus the cosine squared of x, which is more algebra. Again, we kept this the same. We changed this division to multiply, and then we flipped this fraction upside down. And the reason why is that these cosines will end up simplifying. So now, once you simplify it, I have 1 minus cosine squared of x over 1 plus the cosine squared of x, which is some more algebra. Now, I think we're very close to our answer because, let me go back up to what we're trying to find. We're actually trying to write sine squared over 1 plus cosine squared, which, in fact, we just have to rewrite this as sine squared of x because this is that Pythagorean identity. So we are essentially done by that Pythagorean identity here. Just remember that sine squared of x plus cosine squared of x is 1. And if I end up subtracting cosine to the other side, it's 1 minus cosine squared, which is sine squared. That's what we did. We substituted that in. And that's that Pythagorean identity. Therefore, we have verified our identity. So let's do a couple more examples. Here's another strategy I'm going to teach you. This strategy is actually very nice. We're going to create something really, really nice here. We have two fractions. This is 1 over sine, which is pretty nice, but we have sine squared over 1 plus cosine. There's kind of two things on the bottom here. It's a binomial, which is not very nice. So what we can do is we can multiply by its conjugate. So instead of 1 plus cosine, I'm going to multiply by 1 minus cosine of x. Now, if I do that to the bottom, I also have to do that to the top. So we're going to use some algebra skills to distribute all of this out. So we still have this 1 over sine of x that we didn't change, and the top will be sine of x, and this will be 1 minus cosine of x on the top. And the bottom, if I distribute out conjugates, we get positive 1, and then the insides minus cosine and plus cosine cancel out, and we're going to be 1 minus cosine squared of x. So the reason why that is extremely nice is because this changes into a sine. So remember that our Pythagorean identity of sine squared, when we subtract the cosine to the other side, we get that sine squared is 1 minus cosine squared. So what we can then do is 1 over sine is equal to sine of x times 1 minus the cosine of x over the sine squared of x, which is that Pythagorean identity. Now the nice thing is this sine and one of those on the bottom will cancel out. So let's move that up. So then we're left with, oh, sorry, that's supposed to be just a minus sign, not an equal sign. So then we have 1 over sine of x minus 1 minus cosine of x over just one of those sines of x's, which is algebra by canceling those out. And the nice thing about what we just did is now they're both a fraction with the same denominator. Now what we're going to do is we're going to do 1 minus 1, which is nothing, and 1 minus a negative cosine. So we're kind of subtracting everything on the top. So it ends up being a positive cosine of x over sine of x, which is some more algebra skills. Now, the nice thing about that is this is just equal to your cotangent of x, which is just using the last thing, which is your quotient identity, because cosine over sine is cotangent by that quotient identity. And that's what we're trying to get to. If you remember from before, we're trying to get to cotangent. So that would be our final answer. And it is a bit difficult and a tricky thing, but we'll be sometimes multiplying by your things like that. And again, I would write all of this down on paper before you ever try it on Alex, because it's a lot easier if you do it, because then you can just do a few of these steps on Alex. Like, you don't have to write down the crossing out things. It's a lot easier. You don't have to write this on Alex, but on paper you would write this as your scratch work.